First thing we're going to do today is just create another array, and we're going to iterate over it and print out the values in the array. We say int brackets, of course, and then I'll write a for loop. I'll have my for loop go from I equals 0 to less than the length of the array. So create a homework grades array from I equals 0 up to but not including the length of the homework grades. Print out the thing at that index. So that's going to be the thing we start with. After that, I'm going to make an array the other way, which is int brackets, and then I'll have the name of it, so quiz grades. And instead of having the values to start, I'll just say new int, and I'll say there's 2 values in it, and I'll assign to each of those. So now I see my homework grades. I initialize this as an array of 50, 175. Down here I create quiz grades as just an array of 2 ints. They'll both be 0 by default. And then I set each one of these. And then I print the whole thing out. So today what I want to talk about is how we can relate to what the computer does algorithmically, what the steps are to solve a problem and make it something more tangible. So I have in my hand a deck of cards. All right, I'm going to hold these cards up one at a time. At the end, I'm just going to ask everybody to tell me how many red cards they saw. All right, everybody, how many red cards were there? 5. So what are you doing there when you run through this process? Inside of your head, you're just keeping a count. And every time you see another red card, you're increasing whatever that count is by 1. So whether you're doing it on your hands or you're doing it in your head, you're looking at these cards one at a time. You're seeing the 8. You're going, okay, now the count is 1. See this? Or still 1 because we're not adding anything because it's a black card. Then it's 2. Then it's 3. This one we don't count. This one we don't count. Now it's 4. Now it's 5. And then we don't count that one. We're doing the same thing over and over again. That's what a loop is. What we use loops for when we're writing code. Look at every card individually. So for each card in my hand, do something. You start with the count, that's a variable. Your count is equal to 0. For each card that you see, if the card is red, you increase your count by 1. So we can write that in pseudocode. Stuff that's not real code, but it still describes how we get things done. So you can say count is equal to 0 to start, and then for each card in, we'll just say cards is the thing that holds all the cards. If card is red, increase the count, and then at the bottom of whatever this is, return or print or something, whatever the total count is. So this is more or less a textual description of everything you were just doing in your heads. It's a sequence of steps. So whether there are 100 cards or whether there's 5 cards, this same thing is how you're going to count the number of red cards. This loop goes to however many cards there are. Now to make this more in the way that we've been doing our stuff, we would have to have some kind of cards array. So if it's an array of cards, we have that equal to whatever. Our for loop would go from int I equals 0. I is less than number of cards. So cards.length, semicolon, plus I. This if condition we need to make a little bit more explicit. So something like if card.color equals red, whatever red is, increase the count, and then close the loop, and then return the count. So taking that description of it and turning it into a language the computer can understand, not just something the person can understand. We're describing the sequence of steps in Java now. So what if I wanted to instead count the even cards here? Let's look at that. I'm going to take another handful of cards here. I'm going to do the same thing. I'm just going to hold up the cards one at a time. I want you to count how many even numbered cards you see. Okay, class, how many even cards were there? 4. How can we change this to work and do what we want now? What's the only difference? Or let's start with this. What stays the same? So count stays the same, the cards array thing stays the same. What else stays the same? Int I equals 0, right? That stays the same. Anything else here stays the same? I is less than cards.length, that stays the same, right? Because we're still looking at every card, and then plus I. So we're still looking at each card. So this for loop, the thing we're looping over, that all stays the same. We just have to change the if condition because we're not looking for red cards now. We're just looking for if it's even. So how do we check if a number's even? Mod it by 2. So instead of card.color, we can say card.number, %2, and then what? We check that it equals 0. So that's how you check if a number is even. Card.number mod 2 equals 0. Like, you're not doing that in your head. You're not dividing every number by 2 and checking if there's a remainder. You're just looking at it and you can recognize what even numbers are. You all just know how to do that intuitively at this point. But you need to translate that to something the computer understands for the computer to do this work for you. So what we're going to do now, switch over to REPL. I'm going to clear what I have. If you want to keep what you have, that's fine. I'm going to create an int nums, or let's say my nums array. I'm going to put a few values into it. I'm going to create another function called count evens. We got to start this with public static int count evens. It's going to take an array. So now when I say int results equals count evens my nums, I want count evens to return the number of even numbers in the nums array. So when I pass it here, I have 2, 10, 4, 6, and 8. 5 even numbers there. So this result variable should be 5 now. So if I print it, I should see 5 printed. If you just try to run what's up here, it's going to fail because there's no return in this function. So you guys are going to fill in this body here. If you copy down what's up there and just try to run it without making any changes, you're going to get a missing return statement error because that function says it returns an int, but I didn't put any return in there. We have to start a count at 0 because just like in real life when we're looking for even numbers, we start thinking there's 0 so far. I haven't seen any. Then we're going to look at every number in the array. So 4 and I equals 0. I is less than nums dot length plus I. We know at the bottom we're going to return whatever our count is, so we can stick that in right away. And here we need our condition. What are we looking at here? Nums what? It's nums I, so we want the ith element of the array. When I is 0, this gives us the 0th element. When it's 1, it gives us the element at index 1, and so on. We're going to mod whatever we're currently looking at by 2. We're going to compare that to 0. If that's true, then we increment the count. And I get 5 down here because my example has 5 even elements in it. So if I grab some cards from my hand again, I can run through this the same way. So if I have my sequence of numbers right here, this is my array. Your code runs, it's going to ask you for an element. First, you're going to say, give me the 0th element. And you see the 4, so you increase your count by 1. Then you say, give me the element at 1, so I get the element at index 1. And I see a 6, so I increase the count by 1. 7, I skip that, don't increase the count because it's not even. 9, element at index 3. And then the 10, the element at index 4. The length is 5, but the highest index is 4. Again, since we start counting at 0. We're only looking at one element at a time though, so when you're not looking into it, all your code really can tell is that there's an array of some number of elements, but it can't know what they all are at the same time. Unlike humans, where I could just take this, if I wanted to, if I want to count the evens, I could just throw them on the table and be like, 1, 2, 3, 4, whatever. You're still really only looking at them one at a time. This is just a little more systematic way to write it down. So let's grab some more cards. We're going to talk about a different algorithm. The next algorithm is how to find the largest element in the array. You just want to know the biggest number that's in there. I'm going to hold up some cards. I'm going to hold them up one at a time. At the end, you're going to tell me what the biggest card or the largest numbered card or whatever that you've seen so far is. So let's start. Okay, class, what's the largest card you saw? Jack, exactly. Now let's do that one more time with a different set of cards. Each step, I want you to tell me what the largest card you've seen so far is. So I'm going to hold it up. You're just going to say what the largest card you've seen so far. 5. That's the largest you've seen so far. It's the first one.
9.
Still 9. 9 is still the largest card we've seen so far. King. Let's grab a few more because it's a little confusing. King. Yes, it's still king, right. What are the steps here? How can you write this down in a more algorithmic way, like something like this? We still need a for loop. We're still going to look at each element. In the first one, we had the count variable. When we're looking at count evens, we keep that count, and that's the thing that varies. That's the thing we're using to keep track of something. Here, what are we doing instead? Every time I show you a card, what are you doing in your head? You're only comparing it to one other thing. I can show you 50 cards. You're not going to have to remember all 50 cards that you've seen. The only thing that matters, the only thing you need to keep track of is the largest card you've seen so far. If I've seen a king, all I need to remember is that there's a king that's somewhere in the past. I don't care that there's a bunch of 9s and 8s and 4s back there. So the one thing that you're tracking is the largest you've seen so far. On the first card, what's the biggest one you've seen? It's 3, because if the 3 is the first card, that is the largest one. You haven't seen anything bigger than a 3, so you just assume that. But every step of the way, you know the largest one. That's your variable. The thing that you're keeping track of, the thing that keeps changing. Every time you see it, you replace the value that was in there before. How can we write this find largest thing in this shape? We know that the for loop's going to be the same. But what else needs to change? Right, we're not gonna have a count anymore because we're not counting anything. So let's get rid of that. And what are we gonna have instead? I'm asking, what do we need instead of a count? We need the largest. So the way you do algorithms like this, where you're looking for the largest or the smallest of something, is you just begin by assuming the first thing is the largest, because you don't have any other option at that point. So we'll just say card 0 is the largest card. You know, at the bottom, we're gonna return the largest card we've seen, so I can fill that in right away. I'll fill in return largest. What are we gonna do inside of our loop? We're gonna have an if, and what are we checking? We're not just checking it against the previous card, we're checking if it's bigger than the largest one we've seen so far. So if the current card is greater than the largest card, what do we want to do? We don't want to return. Once we return, our function is over. Return is saying, like, this is the output, this is my result, throw this back to the caller, I'm done. We want to replace the largest one. If the card that we're on now is bigger than the largest card we've seen so far, then this card is actually the biggest one we've seen so so far. So we replace largest with the current card. Every time we come around this loop, we're gonna look at whatever card there is, just like you guys did. Look at the current card. That's bigger than the one that we're already remembering. That's the one we remember now, and we forget about the old one. You don't need an else. There's an else, we just don't do anything. Like when I hold up the 5, and the biggest one you've seen so far is a 10, you just ignore it. So for each card, if the card is greater than the largest one so far, we assign the new card, the one we're looking at right now, to the largest one we've seen so far. Then the next time we come around the loop, we'll be remembering the largest one. So let's turn this into code. I'm gonna throw another one up here. Int nums, so same thing as count evens. But what I want you to do instead here is take this pseudocode and turn it into actual Java code that will go through an array of numbers and return the largest one. So again, missing a return statement as I would expect. All right, so everybody, this is what you're doing now. You're gonna copy down the find largest declaration that I have up here, and you're gonna fill in the body. We know what the algorithm is. We know the sequence of steps. We just need to teach the computer how to do it. So we know we're gonna have a for loop. You should at least be able to fill in the for loop part. It's gonna be the same thing as count evens. It's gonna be the same thing as everything else we do that loops over an array. And we also know we're gonna have int largest equals nums 0. And we know we're returning the largest at the end. If the current element is greater than the largest one we've seen so far, the largest equals current element. So we should see 10.